So today we're going to cover the last section that we're going to cover in chapter 4, which is section 8, and it's going to be using isosceles and equilateral triangles. Most of the information in this lesson you've seen before, but now we're going to officially be presented the information as a theorem or a converse or a corollary. But before we begin, let's learn about the parts of the isosceles triangle. So the two sides that are going to be the congruent sides are called the legs. So these will be the two congruent sides. The base, or the bottom here, is going to be the non-congruent side. So it will not be congruent to the other two. The base angles are going to be the two congruent angles that are across or opposite the legs. So the two angles that are across from the congruent sides are also going to be congruent base angles. These are your parts of your isosceles triangle. All right, next is called the base angles theorem. And what this states is if two sides of a triangle are congruent, then the angles opposite them are congruent. So notice on the sides, I've got my tick marks here, my congruency marks. So that tells me that the angles across from them or opposite them are also going to be congruent. The next one is the converse of the base angles theorem. And what that states is if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So the side that's across from the congruent angles will be also congruent. So we can add tick marks there, or congruency marks. So if B is congruent to C, then AB is congruent to AC. And this is the converse of the base angles theorem. So here are two corollaries formed from the base angles theorem and the converse of the base angles theorem. Remember, corollaries are based on theorems. So the corollary to the base angles theorem states if a triangle is equilateral, then it's equiangular. The converse for that, if it's equiangular, then it's equilateral. And again, we've seen this before, but now we're officially learning it as a corollary. Next, let's try to apply this information. See if you can find the values of x in the three examples here. Let me give you a few minutes here to try it. So this tells me that this angle and this angle are congruent because they're across from the congruent sides. Anybody remember how much the three angles of a triangle add up to be? 180. So let's go ahead and subtract out that 30. Now I have 150 degrees left over for both of the angles. And remember, they're both congruent. So to figure out what x is, I'm going to divide it by 2. So x equals 75. Now, on part B, do not get confused and think these are for the angles. Okay? Notice that the 2x minus 4, the x plus 5, the 2x plus 2, these are outside of the triangle. And you do not see any little degree symbols next to it. So these are for the side lengths. Now, notice again, we're going to apply our converse of the base angles theorem. And because I have two congruent base angles, that tells me that these two sides are congruent. Now, this 2x plus 2 is here to confuse you. We do not need this. Okay? Common mistakes that people are going to make. They're going to think they're for the angles, and they're going to try to add the 3 and set it equal to 180. These are not angle measures. These are side lengths. So we're going to set 2x minus 4 equal to x plus 5 and solve for x. Subtract x. X minus 4 equals 5. Add 4. And x equals 9. The last one. What do you think we need to do here? So let's add 56 plus 62, and I get 118. I'm going to subtract that from 180 and find that my missing angle is 62 degrees. Notice I have an isosceles triangle now. My base angles are both 62, so that tells me that the sides across from them are going to be congruent. So if those two sides are congruent, what's x?
42.
Beautiful. So we needed to find that missing angle to figure out which side we were going to put in there, because we have an isosceles triangle. That's a good point to bring up. He said they flipped it on its side to confuse you, so don't always think, like back on that beginning slide where I told you that these are the legs and this would be the base. The isosceles triangle is not always going to sit on the base. They could rotate it, like in this example. Notice the base is over here at the 41. The 42 is right here and right here, so those are your legs. So the isosceles triangle does not have to sit on that base side or the side that's different. So just be aware of that. It can sit any way that they want to put it. All right, let's try the next one. It's asking us to order the statements for our, they're giving us the statements and they want us to put it in the correct order. So I'm going to just go ahead and fill in the proof for you. Now on your test on Thursday, you're not going to get this. It'll be totally blank. All right, so let me just write this as a proof so we can practice. Statements, reasons. So I'm going to, out of these 4 things, I'm going to look for which one is my given. And you can see that that's going to be the last one. So you're going to state that angle 1 is congruent to angle 2, and that was given to us. Gotten rid of 1. Next thing that I can tell from my picture is going to be this one right here, and these are vertical angles. So that'll be my next statement, that angle 2 is congruent to angle 4, and angle 3 is congruent to angle 1, and this is going to be vertical angles theorem. So now that one's gone. Notice C is what I'm trying to prove. So I'm going to state A, which is going to be substitution. They're going to substitute and make 3 can be congruent to 4. And that's substitution. And then now that I've shown that the base angles are congruent, I can use my base angles theorem converse and state that OK is congruent to OJ. And this is by my base angles theorem converse. You can also state it as the converse of the base angles theorem, just as long as you get the word converse in there and base angles. So that would be that proof. All right, so for example 3, let's fill in. Now, I'm going to change this given here. This should really stay angle 1 is congruent to angle 2. So just fix that up. So statements and reasons. Let me state my given. M is the midpoint of AB and angle 1 congruent to angle 2. That's my given. So let me add that in here. Okay. Next thing I'm going to use is my definition of midpoint. So I know that when I have a midpoint here, that's going to split my segment of AB into 2 congruent parts. So I'm going to state that AM is congruent to BM. And my reason is definition of midpoint. Now, the next statement that I'm going to say, I could have put that as 2. So really I could flip-flop 2 and 3. So 3, I'm going to use my base angles converse theorem again. So notice 1 and 2 are base angles of my triangle. So then I can now say that AM is congruent to AC. And this is the base angles theorem converse. And now my next statement is what I'm trying to prove. And the reason will either be substitution or transitive. So I can now state that AC is congruent to BM or MB. And my reason is transitive. Or you can say substitution here. So now I've shown that this one is congruent, and notice all 3 sides are congruent, or all 3 pieces, and that's what they were trying to ask us to conclude, that this side is congruent to this. Okay, so your homework for this is the PDF that's on the assignment.